Time to start lesson 7-7 and called complex numbers. The first thing is you're going to learn about our new friend, the imaginary number, and how we use it with radicals. But I wore a sweatshirt earlier this year, if you remember right, and on it had the imaginary number, and I talked about it at that time. Well, what was it again? The imaginary number is the square root of -1. As we talked with square roots, when there's a negative underneath there, we can't actually do its square root. So mathematicians have then termed this as the imaginary number. We do have a symbol for it. The square root of -1 is called I. It's a cursive I, and it means the imaginary number. And has it allowed us to do? It's allowed us to do more work with radicals that have negatives on the inside, especially radicals that are square roots. So let me show you. There are some patterns with I, and I would like for you to write this down as I show the video to you. So here's what we have. We have -1 is the imaginary number. Okay, if I square both sides, so I do square -1, the square root of -1, and I square I have I squared. What happens on the left side of this equation? That's right, the square root of -1 times the square root of -1 still uses the product rule and gives us an answer of -1. So -1 is the same as I squared. Okay, so let's say we multiply both sides again by I. We started this up here and squaring both sides. We're multiplying by I. So now I have -1 times I on the left side, I squared times I on the right side. What does that give us? That gives us that the opposite of I is the same as I cubed. Okay, so we've got opposite of I is equal to I cubed. Now let's take a look. Let's multiply by I again. The opposite of I times I equals I cubed times I. So I multiply both sides by the imaginary number again. And what am I going to get for an answer? I get the opposite of I squared equals I to the fourth. Let's see, what was I squared? I squared was -1. So let's change this. The opposite times -1 equals I to the fourth. So on the left side, when I say the opposite times -1, that's like -1 times -1, which equals 1. And that's the same as I to the fourth. All right, so what does all this mean? Well, I'd like to make sure that you understand this pattern. That the imaginary number, I want a red marker. So you need to make sure that you understand this. That the square root of -1 is the same as I, the imaginary number. That if you have I squared is equal to -1. I to the third power is the same thing as the opposite of I. So in other words, and then you'd have an opposite symbol out here. So you have the opposite of the square root of -1. Lastly, that if I have I to the fourth, that's the same as 1. So the next question might you have then, okay, let's go on. What is I to the fifth equals? Well, let's see. I to the fifth would be the same as I to the fourth times I. So let's see how that works. I to the fourth times I. So that's like having 1 times I. So I to the fifth then happens to be the same as I, or the square root of -1. All right, so what happens for I to the sixth? I take it times I to the fifth times I, and I equals I times I. Well, I to the sixth is the same as I squared. And I believe you're going to start to see a pattern here. Here we have I, here's I squared. So what does that mean? It means then that I to the seventh is the same as I cubed over here. And then I to the eighth is the same as I to the fourth, and that's equal to 1. So you see there's a repeating pattern here, and it's in a multiples of 4. You have 1, 2, 3, 4, and then it repeats for 4, for 5, and 6, and 7, 8. You'll be spending a lot of time with I and I squared and sometimes with I cubed and I to the fourth, but most of your time will be spent with I and I squared. Okay, so let's take a look here. Let's practice first of all, how do we break apart a number that's an imaginary number inside a radical sign? So I have the square root of negative 36. How do we handle this? You need to rewrite this and you need to show this work on your paper, especially as you're learning this. The square root of negative 36 is the same as the square root of negative 1 times the square root of 36. The square root of negative 1 is called I. The square root of 36 is 6. So when we write our final answer, we will write it as 6I. The irrational number is written first, the imaginary number is written second. So the answer to the square root of negative 36 is 6 times I, or the imaginary number. What do I do when I have something like this? I have the square root of negative 3. Well, that one is much simpler. That is then like the square root of negative 1 times the square root of 3. The square root of negative 1 is I, so I'm going to put I. The square root of 3 does not have a perfect square root, so I'm just going to say I times the square root of 3. And I will leave it this way. I'll put I before I put the irrational number of the square root of 3. So I have an answer at the top here with 6I, and here's one where it's I outside the radical. Okay, so what do I do with something like this? I got the opposite of the square root of negative 50. How do I handle that? Okay, let's break it apart into pieces. We're going to put our opposite sign, 50, then I'm going to put times negative 1 times, and 50 has a perfect square factor to be 25, so it's times the square root of 25 times the square root of 2. Now what? Well, let's put all the things on the outside that we can put outside a radical. Take a look. Now I have a square root of 2 that I'm going to have to leave there, but these other three things can all be on the outside of that. So I'm going to have an opposite of I times 5 times the square root of 2. So how do I write the final answer for this? I'm now going to say that negative 5I times the square root of 2. And that's how we actually handle working with the numbers that are irrational that have a negative. So it's actually an imaginary number. So you'd say negative 5 times the imaginary number times the square root of 2. That's how we would simplify this out with an imaginary number. Okay, and that is it that I want to show you at this time. I do want you to do some work with this before we go any further. Open your book to page 466 and do problems 1 through 8. Please check your answers and keep the work. You're going to put lesson 2 with this work before you turn it in. So give that a shot, and then I'll help you if you need help. Be sure to check your answers. So now it's 1 through 8, so there's even numbers. You're going to have to use my textbook to check your answers. All right, let her rip.